All right, solving cubic and quartic equations. That's what we're going to look at today. So we're going to use some of the basic factoring techniques that we saw with factoring cubics and quartics as we solve our equations today. We're also going to remember that wonderful quadratic formula that we talked about during the quadratic section. So let's go ahead and start with an example. And we're going to notice this is going to be very similar to our problem that we started with when we factored, but now we're making an equation by setting it equal to 0. We're going to solve this just like we would any other equation. If it was a quadratic, we would factor this as much as we could, and then go ahead and set each of the parts equal to 0. With a cubic, we're going to do the same thing. We're going to factor it as much as we can. Well, x to the third minus 27, remember, these are both perfect cubes. So we can factor this to x minus 3. Remember, the cube root of 27 is 3. And then we're going to go ahead and factor or create our trinomial based off of this. So we're going to take x and multiply it to itself. We get x squared. Multiply the two terms together and change the sign, so plus 3x. And then multiply the negative 3 to itself, and we get plus 9. And these are both equal to 0. Remember, our quadratic in our factorization is not factorable. So we're going to take our x minus 3, that's the easy one, set equal to 0, and we get x equals 3. If we take x squared plus 3x plus 9 and set it equal to 0, remember this isn't factorable, so we're going to use the quadratic formula. And we'll put the quadratic formula up here off to the side, so negative b plus or minus the square root b squared minus 4ac all over or divided by 2a. Remember, our coefficients are a, b, and c. Here's your 1 for a, b is 3, and c is 9. So in our equation, we have negative 3 plus or minus the square root, b squared, we have 9, minus 4 times a, which is 1, times c is 9, divided by 2 times a, which is 2. And this is what x equals. Simplifying this, we have x equals negative 3 plus or minus the square root 9 minus 4 times 1 times 9 is 36 divided by 2. Continuing to simplify inside that radical, 9 minus 36, we get negative 27 divided by 2. Well, then the square root of negative 27 reduces. We have negative 3 plus or minus. Remember, 27 is 9 times 3. So we can break this up into the square root of negative 9 times 3 divided by 2. The square root of negative 9 is 3i, radical 3, over 2. Since we can't simplify this anymore, that's going to be our solution. So here are two of our solutions. Remember that plus or minus is one of the solutions. And here's our other, or our third solution, x equals 3. Let's go ahead and take a look at example number 2. In example number 2, let's again use one of the problems that we saw yesterday when we factored cubics. Let's set this one equal to 0. So we have 8x to the third plus 27 equals 0. To factor, we're going to take the cube root of each of those terms. So we have 2x plus 3. Remember, 2x times 2x times 2x is 8x to the third. 3 times 3 times 3 is 27. To get our trinomial, we're going to square the first term. So 2x times 2x gives us 4x squared. Multiply the two together and change the sign. So minus 6x. And 3 times 3 gives us plus 9. Remember that last term is always positive when we factor our cubics. If we go ahead and set our first set equal to 0, or our first term equal to 0, solving for x, we end up with 2x equals negative 3, divide by 2, and x equals negative 3 halves. Over here, we're going to use our quadratic formula again. So we're going to end up with negative b, which is 6, plus or minus the square root, b squared, gives us 36. Remember, a negative times a negative gives us a positive. Minus 4 times 4 times 9. divided by 2a, which is 2 times 4, 8. And that's what our x is. We're going to go ahead and continue to clean up that radical. So we have 6 plus or minus the square root. 36 minus 4 times 4 is 16 times 9. We end up with 144 divided by 8. Continuing to clean up inside that radical, we have 36 minus 144, and that ends up being negative 108 divided by 8. If we look at the square root of negative 108, 108 is 36 times 3. We have the negative in there, so we'll say negative 36 times a positive 3. Remember, we want to pull that negative out as we're working. So we have 6 plus or minus 6i radical 3 divided by 8. Remember, if we can factor out something out of the first or the two terms on the top and with the bottom term, we want to go ahead and do that. So 6, 6, and 8 are all divisible by 2. So we can take a 2 out, and we end up with 3 plus or minus 3i radical 3 divided by 4. And there is 2 of our solutions. Remember, we have that plus or minus. They are complex or imaginary. And we have x equals negative 3 halves. And there are our 3 solutions. 2 here, 1 there. Let's go ahead and look at solving a quartic now. And again, we're going to use the same process that we used yesterday when we factored quartics. So let's take example 3, and let's look at x to the 4th plus 3x squared minus 28 equal to 0. We're going to, again, factor this if we can, and this one does factor. Remember, x to the 4th can break up into x squared and x squared. We're going to multiply to give us negative 28 and add to give us 3. So we can have plus 7 and minus 4 equal to 0. At this point, we really don't need to factor anymore because we don't have that linear term or that x term by itself in either one of these quantities. So we can go ahead and set up the square root method. Remember, in the square root method, we don't have the x or that middle term to deal with. So we can go ahead and solve for x by subtracting the constant and then taking the square root of both sides. And we end up with x equals I radical 7. Remember, when we take the square root, we have the plus or the minus sign that we put along with it. So we have 2 of our solutions there. On the other case, we have x squared minus 4 equal to 0. So we have x squared equals a positive 4, taking the square root of both sides, x equals plus or minus 2. And there's our other 2 solutions. So we have 2 imaginary and 2 real. Let's go ahead and look at one more, example 4, to end our quartic section. And let's look at our 4x to the 4th minus 28x squared plus 48 equal to 0. Here, remember, I can take out a GCF, or common factor, which is 4. So we get x to the 4th minus 7x squared plus 12 equal to 0. Looking at each of these factored, we can take x to the 4th and break it up to x squared and x squared. We can break up our 12 into minus 3 and minus 4. When we just looked at x squared minus 4, setting it equal to 0, we end up with x equals plus or minus 2. And we'll end up with the same thing here. In this case, we're going to set x squared minus 3 equal to 0. Add 3 to both sides, we get x squared equals 3. Taking the square root, we have x equals plus or minus the square root of 3. We can't reduce radical 3, so we leave it. And then the 4, which is the GCF, there's no variable with that, so we really don't worry about it. If we were to set that equal to 0, we should see that that doesn't make sense at all. So we get rid of it. And here are my 4 solutions, plus or minus radical 3 and plus or minus 2. And that ends our solving cubics and quartic equations.